So in the next series of videos, we are going to see about collections in detail. For now, I will just explain about collections in a brief manner. So before explaining about these collections, I will tell something regarding interview process. Whenever you attend any software interview, you would face the questions from these topics, because this is a very basic topic that you need to be very strong. Suppose if you want to be a very good software developer, then you need to be very good in collections, and you need to be very smart in selecting the data structures that suits your use case. If you need to be a very good Java programmer, then you need to be very good in collection topics. So first we will talk about what is a collection in a general thing. Collection is a group of things. For example, suppose if you need to collect the things, collect the chocolates, what you do means you try to use some jar where you will collect a set of chocolates like Perk, Munch, 5-star, etc. So that jar acts as a container or collection. It is collecting a set of chocolates. Similarly, Java also plays that kind of role. So in programming terminologies, collections means collection of data. It can be similar data or it can be unsimilar data. So here the data is collected and it is kept in some place. That some place is called memory. So that's the general meaning of a collection. So in real-time example, telephone directory would be the best example to explain collections. In a telephone directory, you would see many telephone numbers. For each number, you would see the telephone number details. For example, name, address, etc., etc. So here the telephone number acts as a pointer to the respective details. So this also comes under collections. So we will also see how we can create telephone directory using Java collections in the upcoming videos. So first and the second thing what we need to do is we need to know why do we need collections. So here these are the two examples why we need to use collections. The first one thing, grouping of files in a folder. So for example, if you are using a computer, what you do means you would try to create many folders for each purpose. If you create a vacation folder for storing the vacation related files, and birthday folder for storing the pictures, images for birthday related things. Similarly, so here the folder acts as a container to all the things. Similarly, diary. If you want to add some name and the diary, what you do is you just write the names and the diary. So here diary act as a container. So this is also one type of the collection. So general thing what we are trying to say is collection is a group of things. So this is the major uses why we need to use collections. And then comes where do we use collections? So in terms of technical perspectives, whenever data is a dynamic, then we need to use collections. For example, if suppose we will consider YouTube subscribers. If suppose a video has got a good quality and quantity, then the subscribers would increase. If suppose a video doesn't have any quality in terms of things that the video trying to say, then the subscribers would decrease. So here the subscriber is a dynamic variable, so it can increase and decrease. There is no limit for that. So here the collections plays a major role. So we'll talk more about this in the upcoming video. Hi friends, now we are going to see the benefits of collections framework. So we have already seen about the collection framework in brief in the previous video. If suppose you haven't watched this video, please go and watch that video and come to this video. So these are the major benefits and main benefits of this collection framework. So first and foremost thing is reduces programming efforts. So suppose if you need the ArrayList set or linked set, we will talk about this in detail in the upcoming videos. For now, just consider these things. If you need these things in every program that you write, then it's a lot of effort. It's a lot of effort in both in terms of time and also in terms of the money that company provides to you. So it provides this saves the time and effort, and then provides useful data structures and algorithms. Since this is an open thing, many developers have developed these best data structures, and it would have been tested by many testers. So this would be the best data structure and the best algorithms that would be present in the collections framework. And then we can concentrate. We means the programmers can concentrate on other important tasks. So they can use this, reuse this code, reuse these functionalities, and they can concentrate on the high-hanging fruits instead of concentrating on low-hanging fruits. And then it increases the program speed. For example, if suppose you are writing a big software, at that time you need many things, like you need some best data structures to hold the data. If suppose you can use this collection framework, then it increases program speed, and it also increases the things in different ways. It improves the performance. If suppose if you are using a banking application, at that time you shouldn't face any time problem. You should see the transaction in a fraction of seconds. So at that time you need to have the best data structures that would be provided by the collections framework. And high quality code. So in case of a banking application, the things that need to be very secure and transaction needs to be very secure. So programmers can concentrate on that thing instead of concentrate on the regular things like ArrayList, list like that. And then reduces the memory in a great manner. For example, if you use the ArrayList, then you can reduce the memory in a drastic manner. And since that is a dynamic array, that memory increases or decreases dynamically when compared to array. We'll talk more about this in the upcoming videos. We're going to see what are the collections framework that are available in Java. And what is a collection? First of all, what is a framework? So if suppose if you're writing any program, if suppose that program can be used by n number of people in a nice way, then that code would be some framework. If suppose if you're writing a same program but it is useful only for your own purpose or for some custom purpose, then that is not a framework. So generally framework allows you the generic functionalities. For example, in math is a framework. In that math.square root means it just finds square root. Anyone can use it. And then it can be changed using custom user code. If suppose if you don't like that implementation, if you need to have your own implementation, means you can add it. So that is also a part of the framework definition. So now we will see about the collection framework. So actually collections plays a part in the data. It tries to handle the complete group of data. So this architecture stores and manipulates the data. And then it supports and contains various things like interfaces, implementations, and best algorithms, and it supports various operations. Interfaces means we have already seen about the interface in detail in the previous videos. Interface, for example, if suppose there's a bank interface, in that bank interface there is an abstract method called add money. That method name itself defining the functionality is that method is used to add amount. But the implementation is not in that interface. Some class has to implement that interface and need to write the custom code. So that's the basic about the interface. We have already seen about interface in details in the previous videos. And then concrete implementations are provided for these interfaces. So for every interface there is some concrete implementation. If you don't like, and if suppose that implementation doesn't suit your use case, then you can write your own custom implementation. And then since this is an open source community, the algorithms are best algorithms used for these collections. If you have some other best algorithm, then you can also contribute to the community. And then operations, there are various operations supported like add, delete, search, and etc. So these are all bundled under a single name called collection framework. So we'll talk more about this in the upcoming videos. Hi friends, now we are going to see about the hierarchy of collections framework. So this is just an interface class diagram. So please don't get afraid after seeing this diagram. This is just the flow how interface and classes are connected. In the next videos, we would see the detailed things about these things in a nice manner. For now, just consider this diagram. Please try to take notes whenever you watch these videos, because it will be helpful for the long run. If you have any doubt in the after some days you could just refresh those notes that could give the brief information what you had learned in the previous sessions. So we will go into this video. This is the description about this diagram. Whatever written inside this red box is the interface. Whatever written inside the blue box is called class. Whatever this continuous line describes extends, and this dotted line describes implements. The first and foremost interface of the collection framework is iterable. We will talk more about the iterable in the upcoming videos. For now, just consider this is the first and foremost interface. This collection framework, this is the second interface. This interface extends iterable interface. Basically, an interface cannot implement another interface. It can extend another interface. That's why collection interface extends iterable interface. And then there are three interfaces: list, queue, and set. All these three interfaces extends collection interface. Indirectly, it also extends iterable interface. So we will concentrate more about these things. That means the default implemented class that are provided by Java to us. So first we'll describe about the list. So list is a collection of series data. So for example, consider consider a train where the different compartments are connected using some links. So for now, just consider like that. We will talk more about this in the upcoming videos. Queue. Queue means if you are standing in a queue in railway station for getting a ticket, the first person who is standing in the front will get the first chance to get a ticket. So for now, just consider like that. We will talk more about in the upcoming video. Set. Collection of distinct data. For now, just consider that. We will talk more about in the upcoming videos. So this list interface, the default implementations that are provided by Java are ArrayList, LinkedList, and vector. All these strings, all these classes implements list. So the things that are present in the list, the abstract methods that are present in the list needs to be implemented in the ArrayList, LinkedList, and vector. And then comes the queue. Queue, the implemented class is priority queue, and DQ also extends the DQ. So the implemented class for DQ is ArrayDQ. So and then is set. The set, the sorted set extends the set. The implemented class for sorted set is reset. The implemented classes for set are asset and linked asset. So for now, just consider this diagram and just consider the interface and classes. We will talk more about this in the upcoming videos in a detailed manner using programs, and I will try to teach you how to write the programs in an easier manner, and I will also try to give some tips how to crack the Java interview easily. So please try to watch my videos in the series manner. So these are all linked with the previous video and the next video. So please try to videos in the series manner. Thanks. Hi friends, this is Rakesh. Now we are going to see about the methods that are present in collection interface. Generally, the methods that are present in interface is just abstract methods. Abstract method means just a method declaration. The definition is present in the implemented class. So these are the abstract methods that are present in collection interface. If suppose any class that implements collection interface, then that class need to implement these methods compulsorily. So first and foremost method is add. Here we are sending some object as an argument. So what it will try to do is it will try to add this element or object in that collection. If suppose if that operation successfully happens, means it returns true, else false. Add or means the argument, the collection that we have sent as an argument, it will try to add all the elements that are present in this collection in our target collection. If the operation successful means it returns true, else false. Remove means the element or object that we are sending in the argument would be removed from the target collection. If that operation successful means it returns true, else false. Remove means the elements that are present in this collection would be removed from our target collection. Operation successful means true, else false. Return means it's just the opposite to remove all. It will try to remove all the elements that are present in our target collection except from this collection elements. Size means it returns the collection size. Clear means it removes all the elements that are present in the target collection. Contains means it will check whether this element present in our target collection. If it present means then returns true, else false. Contains all means it will try to check whether all the elements that are present in this collection are present in our target collection. If it present means then returns true, else false. Iterator means it returns the iterator object. We'll talk more about them in this iterator in the upcoming videos. True order means it tries to convert the collection to array. And then is empty. It will try to check whether collection is empty or not. If suppose data is present means it returns true, false, else true. Equals means whether check whether this object is present in that. It will try to compare the two collections and returns true if both are equal, else false. As code means it returns the as code of the collection. Thanks for watching. Please try to take these things as note so that it could be very useful in your further sessions. So thanks for watching. Hi friends, this is Rakesh. Now we are going to see about the Iterator interface. So the main usage of Iterator interface is used to iterate the elements in forward direction. For example, if suppose you have some data like 1, 2, 3, you need to iterate the data. You need to go from 1 to 2, 2 to 3 like that. Then Iterator would be the best choice for iterating this content. Since this is an Iterator interface, the methods that are present in this interface are always abstract. Under Iterator interface, there are 3 abstract methods called as, next, and remove. So we will see about these methods using this example. As next. If suppose if we are in this position, if we call this as next method, what it would return is true. The reason behind that is, since there are 2 elements that are present after 1, it returns true. If suppose if we call the same method, if we are present here means then return false, because there are no elements after 3. And then next, if suppose if you are here and if we call this next method, it would return this data, and at the same time the cursor pointer moves here. If suppose if we are in this position, if we call this method, it returns this data and pointer moves here like that. Next method works. And then remove. If suppose if you are here and if we try to call this method, it will try to remove this data. So these are the 3 abstract methods that are present in Iterator interface. We will talk more about the content more about the other things in the upcoming videos. Thanks for watching. Hi friends, this is Rakesh. Now we are going to see about the list interface in detail. So list interface, as name suggests that it is an interface. So the interface, the basic definition of interface is it contains some abstract methods. It contains only the method declarations. So the method definitions need to be in the implemented classes. Similarly, list interface contains only the abstract methods. The actual implementation would be available in the implemented classes like ArrayList, LinkedList, like that. So then it extends the collection interface. So the abstract methods that are present in the collection interface also moves to the list interface. The basic definition of the list is it can contain duplicate values. For example, 1, 2, 1, 3. So here 1 repeated 2 times. So it contains repeated it can contain duplicate values. So you can access the values by the position. So you can access the you can access the object using position. You can get the values from index 0, 1, 2, 3 and etc. This is the basic definition of the list. We'll talk about more about the array list, linked list in the upcoming videos. These are the abstract methods that are present in the list interface. The first one is public void add int index object group. So what it does try to convey is it will try to add the object in this index position. For example, if we send 1 and 5 object means, then it will try to get here, it will try to add that object here, and it will try to shift the cells. It will try to move these 2 objects here, 1 object here and 3 objects here. So it tries to shift the remaining objects in the adjacent cells. So next one is public boolean add or int index collection C. So here the elements that are present in the collection C would be added from that index position. And then public object get index. If suppose if you are sending 1 as a value means, it will try to return the object for this data. If suppose, we will talk more about this public int last index of object 0. So before that we will see this public int index of object 2. If suppose if you are sending 1, suppose if it matches one or twice, one or many times, it returns the first index position. So here 1, 0th index, so it returns this object public int last index of object 0. This is the opposite of this method. It returns the last index. So if suppose if data is repeated in the list means it will try to return the last index. Here 1 repeated twice, so it returns this position 2. We will talk more about this in the upcoming videos. List iterator. And then comes the public object remove int index. If we suppose send 1 as argument value, then it will try to find this. It will try to remove this data and it will try to shift the cells from second to 1, third to 2, like that. And then public list, sublist, int start and int end. Here, if we send 1 and 2, it will try to return the elements, return the sublist from that start to end position. 1, 2, so 1, 2, it will try to return this sublist. So hi friends, this is Rakesh. Now we are going to see about the ArrayList. So ArrayList is a class that extends AbstractList. The AbstractList implements list interface. So basically the methods that are present in the list would be present in the AbstractList. So first we will talk about the ArrayList in a brief manner. What is ArrayList? It's a dynamic array for storing data. If you have some basic knowledge about the Java, then you would know about this syntax. Here we have declared an array of type int with size of 10. So the drawback of array is array. It's not a list. The drawback of array is we have to define the size. If you are adding 11th element here, then it would throw array out of bound exception because the memory is defined. Whereas in here it dynamically extends. It dynamically increases its memory when the memory overflows. So that's the main power, that's the main feature of this array list. And it can contain duplicate values. Here we have added 1, 2, 1, 3. So 1 repeated 2 times. So it allows the duplicate values. Maintains insertion order. If suppose we are adding the elements like 1, 2, 1, 3, then it maintains insertion order. So 1 at 0th index, 2 at first index, 1 at second index, and 3rd at the 3rd index. And allows random access because it works on based on index. If you want to access the second index element, then you can directly access this data without iterating from this 0th element to the second element. Manipulation is slow. The reason behind that is if you need to add element at first position, then the elements that are present at the first position need to shift to the second position. From element present in the second position need to be shifted to the third position. So that shifting process is very costly. That's why the manipulation is slow. And retraining is possible if you know the position. The reason behind it is if you know the position, then we can directly access the element without any iterating the elements. If you know the your relative address, you can directly go to the relative. So that's the power of the ArrayList. So hi friends, this is Rakesh. Now we are going to see about the constructors that are present in ArrayList. So basically you know about the constructor and the uses of constructor. If you need to create an object, you could use the constructor to create an object. So ArrayList provides 3 different ways to create an object. The first one is empty ArrayList. So empty constructor. Using this constructor you could create an object, but the object would be an empty object. There won't be any elements in that object. Using the second approach, you could create an object for ArrayList. Inside that, if you send the collection as an argument, then you could create. Then the outcome of that object would be an ArrayList object that contains the values that are present in that collection. And then you could also send the capacity while creating the constructor, while creating the object. the default capacity would be 10. If you know the capacity, then you could send that the capacity value. That would be very useful for optimization purpose. I will explain that in this context. So this is syntax for creating the empty ArrayList object. So ArrayList class name, names list object, new keyword, ArrayList class name, and semicolon. So names list is an object of the ArrayList. So the reason behind that capacity is, if you need to have 11 elements, if you are not providing the capacity, then default there will be 10 cells. If suppose you are trying to add the 11th element, then using this formula, the ArrayList size grows. So our old capacity is 10 into 3 by 2 plus 1 results 11, 16. So the size of the ArrayList would be increased from 10 to 16. Here, the total elements that need to be added is only 11, but the size got increased to 16. So the 5 cells memory is getting wasted. So that's why that's the reason why we need to specify the capacity if we know the capacity in before. If you don't know the capacity, then it's not a problem. If you know the capacity, then it will be better for the optimization purpose. So now we are going to see a sample program using ArrayList. So you would be very familiar with this fragment. So I will concentrate only on this part. So here we are trying to create an ArrayList object called books. You would have a doubt why we need to send this string inside the Angular brackets. The reason behind this, collection is still generic. It would be better if you send the data type. If you haven't sent means, then any data can be any data type, any data of any data type can be added under books. Here you know that books can handle only the string data, then it's better to send the string data type. So here the books is restricted to string based ArrayList. So here books.add C. So this constructor resulted in the empty ArrayList. When you execute this statement, at the 0th index C would be added. Books.add C++. Since at the 0th index C is present, at the first index C++ would be added. Books.add Java. At the second index, Java would be added. This shows that the ArrayList maintains the insertion order. And then we are trying to print the ArrayList content. So C++ Java. And then what we are trying to do is we are trying to add the Python at the first index. Since already some element is present at the first index, what it would happen is it will try to shift the elements that are present in the first index to second index. So C++ moves from first to second, Java moves from second to third. So the outcome would be 0 position C, first position Python, second position C++, third position Java. And then what we are trying to do is we are trying to print these content. So C, Python, C++, Java. And then we are trying to remove C from this list. So book.remove C. So what we are trying to do is we are trying to remove C. Since C is present at 0th index, the elements need to be shifted towards the left. So Python shifts from the first to 0th index, C++ from second to first, Java from third to second index. So in the next video, I would have explained the same program using NetBeans. There I would have executed the output. So it would be very useful if you see that video also. So you could also write your own program. I have also uploaded this code in the GitHub. So you can just download that code and you can execute in your machine. Thanks for watching. Hi friends, this is Rakesh. Now we are going to see when we should use ArrayList when compared to other collections. So the best things that you need to consider is these two statements. So whenever the addition deletion operation on list condition is other than end position, then you should prefer ArrayList. And then accessing the elements using index, then you should prefer the ArrayList. We will discuss about these statements using some use cases. So consider there are 4 data, Rakesh, Lenin, Raja, Lenin at 0, 1, 2, 3 indexes. If you are trying to delete Lenin data, then internally what it happens is it will try to shift the data that is present in the second index to the first index and then from the third index to second index. So the resultant outcome of this structure becomes this. So 0, Rakesh, 1, Raja, 2, Chinchu. So the shifting of cells is a very costly operation. And then consider the second case. add sudo at the first index. So if you suppose if you're trying to add the first index, then the data that is present in the first index needs to be moved to the second index, and the data that is present in the second index need to be moved to the third index. So the resultant structure is this. So this is also a costly operation. And then the second point, as I accessing the elements using index. If you know the index that you need to access, then you can directly access the data that is present in that index. So you don't need to iterate all the elements to find to point that value. You can directly point using index. These are the two statements that you need to consider by preferring the array list over other collection things. Thanks for watching. Now we are going to see about our array list. So basically, what is an array list? Array list is a class that implements list interface. So this is the array list. So this array list is an inbuilt library that was provided by Java. So array list implements list. So basically here angular brackets inside that that's E alphabet. It implies that array list is a generic class. Basically generic class. Whatever the data type that you sent in the generic class, then it will act as that data type object. Example here array list string. So what it does is the books will treat as the array list of string object. So if you send integer, it would be treated as array list of integer object. If you send a float, means array list of float object. So now we'll see how array list methods are used. So first, initially what we are trying to do is book.size. Initially there are no data present in the book, so book size will return 0. And then what we have done is we have added C, C++, Java. Suppose if in this statement we have added C, so C would be at present at 0th position, and then we have added C++. So C would be present at 0th position, C++ would be present at first position, and then we have added Java. C 0th position, C++ first position, Java second position. So what the add method implies is, so whenever we add an element without any index, so it will add at the end of the list. So here 0, 0, 1, 0, 1, 2, and then we are trying to print the size. Initially book size would be 0, now it would be 3. So if we run this thing, you would see 0, 3, C, C++, Java. And then what we are trying to do is we are trying to add a Python at index position 1. So initially this would be the case, C at 0th position, C++ at first position, Java at second position. Here we are trying to add Python at the first position. So there won't be any change for C position. So C would be present at the 0th position. Python would be added at the first position. So C++ would be moved from first to second. Java would be moved from second to third. So this is the new list. So now if you run this thing, you would see that C, Python, C++, Java. And then what we have done is we are trying to remove the C object or C data from books. So this is the existing C at 0, Python at first, and C++ second, and Java 3. So if you remove C, means the C would be removed from the 0th index. So Python would be moved from first to 0th index, C++ from second to first, Java from third to second. So this would be the result of that list. So if we run this thing now, we would see that Python, C++, Java. So this is a basic example how ArrayList can be used in Java. We will talk about more about LinkedList and the related contents in the upcoming video. Hi friends, this is Rakesh. Now we are going to see about the brief introduction of LinkedList. So LinkedList is one of the important topics that is present in the Java collection. So LinkedList, actually this is the class interface extends implements diagram. LinkedList extends abstract sequential list. LinkedList extends abstract sequential list. Abstract sequential list implements list. At the same time, LinkedList also implements DQ. This is the basic thing about the linked list. So you should be aware about this thing. So you should know what it extends and what it implements. And then Java linked list uses double linked list data structure to store the data. If suppose if you haven't aware about these data structures, I have explained them very brief manner. If you want in a detail, please comment those things in the comment box. I will try to take videos for that also. So double linked list. This is the double linked list node structure. Here, this is a single node. Inside the mid one is the data node, data to hold the data, and this is the previous node address. This is the next node address. So, for example, consider these three nodes. So, first node has Rakesh data, second node Lenny, and third node Raja. So, since this is the first node, there are no previous nodes for Rakesh. So, the previous node address would be null. The next node address for the Rakesh will be 101 because the next node is the Lenny. The Lenny address is 101, so 101 will be present here. When we consider about the second node, the Lenny, the previous node address is 100, so that would be present here. The next node for Lenny will be Raja. The Raja address is 102, 102 will be here. So when we talk about Raja node, the previous node address is 101, so 101 will be here. There are no next nodes, so the address will be null. So this is the general brief description about the doubly linked list data structure. If you want in detail, please comment those things. I will try to take videos for that also. Thanks for watching. Hi friends, this is Rakesh. Now we are going to see about the linked list important points or important features. The first point is can contain duplicate values. It's very similar to ArrayList. ArrayList also allows a duplicate values. Maintains insertion order. It is also similar to ArrayList. It also maintains the insertion order. Insertion order means it maintains the position where the data got added. For example, Rakesh got the 0th position, Raja first position, then second position. Like that, it maintains the insertion order. And then it is non-synchronized. It is the same point applies to ArrayList also, non-synchronized. We'll talk more about this, the non-synchronized, in the upcoming videos. When we focus on grid concept, then I will explain this non-synchronized concept. Manipulation is fast since no shifting needs to be happened. This is the only point that differentiates between the ArrayList and LinkedList. In case of ArrayList, the manipulation is slow. In case of LinkedList, the manipulation is fast because no shifting needs to be occurred in case of LinkedList. So I have already explained about this doubly linked list structure in the previous video. If you haven't watched that video, please go and watch that video and come to this video. So the use case is add Sudha at the first position. So what we are trying to do is we are trying to create a Sudha node. Sudha, previous node address null, next node address null. So if we need to add this Sudha node here, then we need to find this Sudha node. The previous address of Sudha node should point to Rakesh node address. So Rakesh node address is 100, so it becomes 100. And then since we are adding the Sudha node the first position, the Raja moves to the second position. So Sudha node next address should point to the Raja node address 101. So that's why we are putting 101. So finally we have created this Sudha node. Now we need to insert here. If we need to insert here, then we need to change the address of Rakesh next node because now Rakesh next node points to the Sudha's node. So Sudha's address is 103. So Rakesh next node address is converted from 102 to 103. And then Raja's previous node is pointing to Raja's previous address is now pointing to Sudha instead of Rakesh. So 100 is changed from Raja's previous address is changed from 100 to 103. 101 to 103. This is the final double linked structure after adding Sudha at the first position. So if you need to explain this thing in the detail, if you want to view that video, please comment those things. Hi friends, this is Rakesh. Now we are going to see about the linked list constructors. Java linked list constructor. There are two types of constructors that are supported by Java. One is empty constructor. Another one is the constructor with collection as an argument. The first constructor we try to create an empty linked list. So the second constructor tries to create a linked list and it tries to add the value that is present in the collection object. So if suppose there are n10 values that are present in collection object, then the elements would be added in the order that were present in the collection object. So this is the example how to create a linked list object. Linked list class name object equal to new linked list encoder. In the upcoming videos, you will see more about this linked list in detail. So thanks for. Hi friends, this is Rakesh. Now we are going to see about the linked list methods that are supported by Java. So these are the most frequently used methods. The first one is void add int index object obj. What it does is it will try to add the object at that specific position. Consider these 4 nodes: Rakesh, Lenin, Rakesh, Raja at 0, 1, 2, 3 positions. Suppose if you are trying to add the Sudha node at the first position, then you need to send 1 comma Sudha. What it will try to do is it will try to add those node here, and it will try to shift the address, not the cells. Now it will don't move the entire data to the adjacent cells. It will just place something. We have already seen about that in the previous video, how that shifting happens in linked list. Next one, void add first. What it does is it will try to add a new node here before the existing list. Void add last means it will try to append the node at the end of the linked list. Boolean add. These two things are very similar. This also adds node at the end. Boolean contains. What it does is it will try to check whether the given object is present or not. Suppose if you are sending Rakesh here, then you will try to return true. Suppose if I try sending Sudha, there are no nodes present in this thing, then it will return false. Boolean remove object. What it does is it will try to remove the first occurrence of this object. For example, here Rakesh is present at the 2 positions 0 and 2, but it will try to remove the first position, first occurrence index node. So here 0th position gets deleted. Get first. What it does to tries to do is it will return the first node data or first node object. Get last. What it does is it will try to remove. It will try to return the last node object. Index of object O. What it does is it will try to return the index of the object. Suppose if the object is present 2 or multiple times, then it will return the first occurrence out of the object. Example, Rakesh is present at 0th index and also at the second index, but it returns the 0th index value. So it returns 0. Int last index of object O. It's opposite to index of. It returns the last occurrence of that object. Here 2. 2 will be returned. So these are the things these are the methods that are supported by Java. So in the previous video we would have seen the detailed information about ArrayList, and we would also written the programs for ArrayList and also for LinkedList. In this video we would see the similarities and differences between ArrayList and LinkedList. So first we will see the similarities. The first and foremost similarity, both implement list interface. So in the previous video you would have seen about the hierarchy of the collections, interfaces and classes. At the time you would have noticed this thing that ArrayList implements list interface, and also LinkedList also implements list interface. So what it tries to convey is both ArrayList and LinkedList has these abstract implemented things. So both maintains insertion order. Insertion order. For example, suppose if you're adding 10 elements, the first element at the first position, second element second position, like that. So this ArrayList and LinkedList maintains that order. Now we will come to the differences. The first difference is ArrayList is the internal implementation of ArrayList is using dynamic array. So that's the power of this ArrayList. Dynamic array means if suppose we will consider an example of an array. In array, the total capacity is defined before we add the elements. In case of ArrayList, the size is not predefined. It can double or triple its size when it exhausts that capacity. But LinkedList uses a doubly linked list structure. So doubly linked list structure means I have already explained about doubly linked list structure in the previous video. Suppose if you haven't watched those videos, please go and watch those videos. And the second point is manipulation is slow because consider these things. If there are 10 elements, if suppose if we are trying to delete the 5th element, means the elements that are after 5th needs to be shifted one position before. That's the reason why manipulation is slow. Whereas in case of linked list, the manipulation is faster because the shifting operation is not happening here. Because the basic data structure of linked list is nodes. Each node points to another node using some memory address or some pointer like that. So that's the reason why manipulation is faster. There is no shifting operation. Only 3 nodes involved while adding or while deleting. That's the power of linked list. And then comes the ArrayList acts just as a list because it just implements list interface, whereas linked list acts both as a list and also as a queue. The reason behind for this is it implements list and DQ interfaces. If you have watched that collection hierarchy video, you would have noticed these things. If suppose you haven't watched, please go and watch those videos, and at the same time try to take the notes for these things, because these things will be asked in interview wherever you go. And then comes to the 4th point, better for storing and accessing. ArrayList is better for storing and accessing. The reason behind it is dynamic array. This is the reason for this point. See, if we know the index, we can directly point to that data. That's the power of ArrayList. Whereas in case of linked list, it's better for manipulation. Suppose if you're trying to delete and add new data, then we should prefer only the linked list over ArrayList. These are the differences and these are the similarities of ArrayList and linked list. Thanks for watching this video. Please, now we are going to see what is a linked list and how we can use linked list in Java, and what are the real-time examples of linked list. So before proceeding to linked list, we would try to relate linked list with the train compartment example. For example, if suppose if there is a train with 12 compartments, each compartment is linked to another compartment using some chain. So that is called the real-time example of linked list. So in linked list, each element is linked to another element using some link. Technically, it's called pointing address, whereas in the real-time example, it's called some link, chain link, like that. So internally, linked list uses doubly linked list data structure. I have already talked about the doubly linked data structure in the data structure videos. Suppose if you haven't watched, please watch that doubly linked list data structure video and then come to this video. Otherwise, you can just Google what is a doubly linked list data structure. Anyway, I will give brief info about the doubly linked data structure. Doubly linked data structure example, the same example, the train example. Here, each compartment has 2 links at the front end and at the back end. At the front, the link that is present in the front end is used to connect the compartment that is present before that compartment. And similarly, the link that is present at the backside is used to connect the compartment at the back end. So we will see the usage of the double linked list in the further videos. And then linked list is used for adding and removing a tail. For example, you can add 4 or 5 compartments easily at the end of the existing compartment, at the end of the last compartment. So if suppose if your train has 12 compartments, you can easily insert the 30th compartment at the end of the 12th compartment. So if suppose if you want to remove the 12th compartments, you can easily remove 12th compartment without touching the other compartments. That's the power of linked list. So now we will see what are the differences between the ArrayList and linked list. In the previous video, I have already talked about the ArrayList and how we can use ArrayList in Java. If you haven't watched, please watch that video and come to this video. What are the differences between ArrayList and linked list? ArrayList internally uses dynamic arrays to store elements. So we can treat this as an apartment. If apartment has 10 floors, if you are residing at the 0th floor, your parents are residing at the 1st floor, and your cousins are residing at 2nd floor, etc. So this is similar to that. So each floor is called an index technically. So you can easily point the actual data that is present in the index. So it's very easy and very easy to retrieve the data. That's the power of ArrayList. Whereas in LinkedList, that's not the case, because LinkedList don't have some specific index. LinkedList elements are spread across the memory, so it can be present besides you, it can be present very far from the current element, like that. So the retrieving process is very slow in the linked list, because you don't know the index where the element is actually present. So since it is spread across the memory, you can't easily retrieve, whereas in ArrayList the elements are present at the successive blocks. And manipulation in ArrayList is slow because it internally uses array. If any element is, we can consider an example. So if you arrange the books in an order, so first book, and on the first book you have kept the second book, on the second book we have kept the third book, like that. So if you want to remove fifth book from the 10 books, what we will do, you will first remove the fifth book, and then automatically the sixth book moves to the fifth book position, seventh book moves to the sixth book position, like that. So here the operation is very costly. So the books that are present above the fifth book needs to move from its original position to one position backwards. Whereas in linked list that's not the case, because in linked list the books are placed across the table. So example, first book are placed on the one end of the table and the second book is placed at the other end of the table. So you can easily remove the books that are present on the table but distributed across the table. That's why manipulation linked list is very fast when compared to ArrayList. And then ArrayList is better for storing and accessing data. So I have already talked about the output. Since we know the index, we can easily point to that element. Whereas in linked list, we don't have that index. So we need to iterate each book or each element to reach the final element. So these are the major differences. So actually, in code wise, the only difference is in the previous video I have used ArrayList here in these two places, whereas here I have used LinkedList. Otherwise the code remains the same. The internal things are technical things differs. If we run this code, we would see the following output, because first we have added C, then C++, and then C++ Java. So here I am just summarizing the information, summarizing out why we got this output. If you want to see in detail, please go and watch the ArrayList video and then come to this video. So C++, Java, and then what we are trying to do is we are adding one at the first position, Python. So C, Python, C++, Java, and then what we are trying to do, we are trying to remove C. So then Python, C++, Java. So please go and watch ArrayList video and then come to this LinkedList video for getting more information and detail. We're going to see about the brief introduction about set. So set is one of the important topic that is present in collection. This would be the important topic for interview purpose also. So the one line difference of a set is it cannot contain, it cannot allow don't allow the duplicate values. So this is single line definition for set. For example, if suppose there are n numbers and if suppose some numbers are getting duplicated, then it won't allow the duplication. It can contain values of only one time. So that is the introduction or brief information about this set. We will discuss about this set in detail in the upcoming videos. For now, just consider this example where the set is used in real time. Lottery winning selection system. Lottery winner selection system. So if suppose there are only totally 8 tickets are available, the winner would be only one person. Suppose Rakesh is holding 100 and 102 tickets, Lenin 102, 103 2 tickets, Raja 104 1 ticket, Chinchu 105, 106, 107 3 tickets, and the probability for winning for Rakesh would be 1/4, and for Lenin 1/4, and for Raja 1/8, and for Chinchu 3/8. If suppose for our case is very close to this selection team, is trying to corrupt, he is trying to bribe that team using some money. Is what he trying to tell is he is trying to tell the selection team to duplicate his values so that the probability of becoming a winner would be high. So 2 by 5. So if suppose the system is using set means then it won't allow this operation because already 100 is present, so it won't allow this duplicate value. Already 101 is present, so it won't allow this duplicate value. So that's the power of set. So set won't allow the duplicate values. That's a single line definition. For more details, please watch the further videos. Now we are going to see about this set interface method. As name itself suggests, set is an interface. So under interface, we would see some abstract methods. The actual implement of those methods would be present in the implemented classes, like as set, linked as set, tree set, etc., etc. So these are the frequently used abstract methods that are present in the set interface. So we will try to explain. Explain about these things using some example. So this is a existing state set that contains 1, 3, 5, 4 data. If suppose we are trying to invoke this method, what it will try to do is it will try to add an object in the existing set. If suppose we are sending 6 as an object, then it will be added at any place. If we need to maintain order, insertion order, or if we need some sort, means there are some specified implemented classes like as set, tree set. We'll talk more about those things in the upcoming videos. For now, just consider if you invoke this method, it will try to add an element. If suppose if you are sending 5 here, then the 5 is already present in the existing set, then it won't be added here. It don't allow the duplication. So next one is clear. It will try to remove all the elements that is present in the existing set. Contains, it will try to check whether the element present in this set, if it's present means then it will return true, else it returns false. If suppose if we send 5 means it will return true, if we send 6 means it will return false. Is empty, it will try to check whether a set is an empty, whether set doesn't contain any elements at all. If suppose the set has some elements means it will return false. If suppose the set is empty means it will return true. Iterator, will talk more about this in upcoming videos. For now, just consider when we invoke this method, it will return some iterator object. Remove, it will try to remove the specified object. If suppose we are sending 5 means it will remove this object. Size, it will try to count the number of elements present in this set, and it will try to return the total elements count. For example, 1, 2, 3, 4. It will return 4 for this set. Thanks for watching this video. So now what we are going to see is set. What is a set interface and how set interface is used in Java, and what are the real-time use cases where set is majorly used. So before moving to that, we'll see what is a set. So set is basically a holder that holds only the distinct values. Example, roll number, and then some unique IDs like that. So here the repetition is not allowed. So set basically don't allow the repetition or duplicate elements. So even if you had multiple entries of the same value, it treats as a single entry. So it won't allow the repetition. So this is set interface. If suppose if you want to see the actual abstract methods that are present in the set interface, you can just click on this set and go to the set interface abstract methods. If you want to see the abstract methods, there will be many abstract methods. So what I have done is I have picked out the majorly used abstract methods. So first we will see add. Add is used to add an element in a set object. So clear means it removes all the elements from set object. So contains means it check whether the particular object is present in that set object. If yes, it returns true, else false. Is empty, it checks whether set is containing any data or not. If suppose if it doesn't contain any data, it returns true, else false. Iterator means it used to iterate each element present in the set, and we can do any operation using that element. And then remove. Remove means we can remove a particular element from that set size. Basically, we used to return the size of the set object. So we will see about each method in detail in the further videos. Now we are going to see about the hash set in a brief manner. In the upcoming videos, we will see these thing in a detailed manner. So for now, just consider hash set is a class that implements set interface indirectly. So the methods that are present in the set interface would be present in the hash set in an implemented way. Here, it uses hash table for storage. We have seen about the ArrayList and LinkedList. In those collections, the ArrayList uses a dynamic array for storage, whereas LinkedList uses Doubly linked list data structure for storing the data, whereas hash set uses the hash table for storage. We will talk more about the hash table in the upcoming video. For now, just consider it's a hash table, and then stores elements using hashing mechanism. So hashing mechanism is a complex and the somewhat complex technical topic. We will cover that hashing mechanism in the one of those videos in the upcoming videos. For now, just consider hashing mechanism. What it does is it will try to generate a hash code for the given data. If you are sending our case as a data to the hashing mechanism, it will try to generate the hash code for that. We know this point. Since this is implemented classes of set, it will contain only unique elements. Thanks for watching. We are going to see about the constructors that are present in hash set class. So these are the three constructors that are supported by Java. The first one is empty constructor. Hash set, inside the argument there are no empty arguments, so it will try to create an empty hash set object. Second one is hash set. We are sending collection as an argument. So what it will try to do is it will try to create an hash set object and then populates the elements that are present in the collection. So if suppose there are 2, 3, 4, 5 data is present in collection C means, then it will try to populate those elements in the newly created object. Hash set int capacity. What it will try to do is it will try to create an empty hash set and assigns the capacity value. And the assigns the capacity. If suppose we are trying to add elements that is over the capacity number means it will automatically try to grow the capacity. So that's the power of these collections. This is the syntax for creating the empty object. Hash set class name, roll numbers is object, new hash set. So this is the object. Using this object you can play the operations like add, subtract, add, remove, is empty, like that. So now we are going to see about the linked hash set in a brief manner. So what's a linked hash set? This is one of those implemented classes of set. So it follows all the rules that are present in the set definition. The first definition of set is it contains only unique element. So linked hash set also follows that principle. It contains only unique elements. So this is a class and interface hierarchy diagram. Here linked hash set extends hash set. So indirectly implements set interface. So the methods that are present in the set interface will be implemented in the linked hash set also. The unique feature of this linked hash set is it maintains insertion order. In the previous video, we would have seen the hash set thing. The hash set doesn't maintain any order, whereas linked hash set maintains the insertion order. So we'll see the insertion order maintenance in this example. Using this example. For example, if you have empty linked hash set object, if you are trying to add an element called 1, then it will be present here. Suppose you are trying to add a second element called 2, 1, 2. So first here, second element here. If you are trying to add an element called 1, it won't add it because it already contains the one element. So 1, 2. So this statement proof is 0. And if you are trying to add another element called 0, it will try to add append at the end of this thing. So it won't append the thing, it will try to maintain the position. It will try to maintain the insertion position. So 1, 2, 0. First element added, second element added, third element added. So the proof for this thing is here. So we are going to see about the constructors that are present in linked hash set. Basically 4 types of constructors are available here under linked hash class. The first one is empty constructor, empty linked hash constructor. Using this constructor, you can create an empty linked asset object. The second type constructor is linked asset. Inside that argument collection string. If suppose you are trying to create an object using this constructor, then the elements that are present in this collection would be added in the newly created object. For example, suppose a collection has 2, 3, 4, 5 data. If you send as an argument, then the new object would contain those data also. The third type of constructor is linked asset into capacity. So we will talk more about this capacity and load factor in the next video. Please try to watch that video also, because that is important thing in terms of interview point of view, and it is also very important to know the technical internal details of linked asset, how it works using this capacity and load factor. The fourth one is linked asset into capacity and load factor. For example, if suppose you haven't send any capacity or load factor, then the default capacity would be 16 and default load factor would be 0.75. So please try to watch the next video. It's a very important video and it will be the continuation of this video regarding this capacity and load factor. So now we are going to see about the linked asset initial capacity and load factor. These are two important terms that you need to remember throughout your career. The initial capacity is when we create a new linked asset object, we can send the initial capacity. That is the initial buckets that the object can hold. And the load factor is a new term that would be explained in this video in a detailed manner. Load factor is the measure of how the asset, when the asset needs to be rehashed, that the load factor decides that thing. Using this formula, load factor into capacity. Whenever the elements are total number of elements that exceeds this formula, then the elements that are present in the existing hash table would be migrated to the new hash table using rehashing mechanism. For example, the load factor value is 0.5 and the capacity is 10. If suppose 10 into 0.5 is 5. If suppose a 60 element is getting added, then the rehashing happens. Rehashing means the elements that are existing in the existing asset object would be migrated to the new asset object by using rehashing mechanism. So the capacity would be increased from 10 to 20, then the elements would be rehashed. So the best load factor value would be 0.75 according to Java. So if you need to change it, then you can change, but you need to maintain that space and time complexity. So thank linked asset. So before going to that, please go and watch the asset video if you haven't watched it. So that was uploaded in the previous video. Please go and watch it. Otherwise, you won't get the complete information about the linked asset. So you would see the difference between asset and linked asset. The major and only difference between the asset and the linked asset is asset doesn't maintain the insertion order, whereas linked asset maintains the insertion order. Here, Rakesh, Lenin, Rakesh and Raja. If suppose if we run this code, we will see Raja, Lenin and Raja. Sorry, Rakesh, Lenin and then Raja. Suppose if you run the same thing using asset, means what we will see is Raja, Lenin, Rakesh. The reason behind this is linked asset always maintains the insertion order. So that's the major difference between the linked asset and asset. So for knowing about the further methods and operations, I've already uploaded that. I have already talked about that in the previous video. So please go and watch the asset video, so you would definitely understand about the linked list. Also, the only difference between linked asset and asset is asset doesn't maintain order, whereas linked asset maintains the insertion order. So once again, thanks for watching the channel. Now we are going to see about the tree set in a brief manner. So actually, tree set is one of the main implemented classes of set interface. So it implements the set interface in an indirect manner. So we will see the thing in this class interface hierarchy diagram. So tree set implements navigable set, but navigable set extends sorter set extends set interface. So indirectly, tree set implements set interface. So the methods that are present in the set interface would be implemented in the tree set also. That's why tree set is the implemented class of in a set interface. Since this implemented class of set interface, it follows the principle that follows the set interface principle. The set interface principle is no duplicate values are allowed. So the same thing is followed here. And then the important thing is the data structure that used for storing the data in tree set is free. So if you haven't studied about the tree data structure, please try to comment the specific thing in the comments of this video so that I can take the video for that alone. So for now, just consider this a tree. So 3, 2, 1, 0, 5, 6. If you are trying to add a new element, 7 means it would be added here like that. The default accessing order for these three set is ascending order. In case of hash set, there is no order; it's a random thing. In case of linked hash set, it's a insertion order is maintained. Whereas in this, the sorted order bears object sorted order. Here, 3, 2, 1, 0, 5, 6. If you are trying to access the element, then the elements will be printed in this field 0, 1, 2, 3, 5, 6 in ascending order. You can also custom the sorted order based on your use case. You can also do the descending order or the custom sort order. We will see more about those things in the upcoming videos. For now, just consider the default order for this is ascending order. And then access and retrieval times are very fast. The reason behind that is the data structure. Here we are using tree. That's the reason why the access and retrieval times are faster. We will talk more about those things in the coming videos. So now we are going to see about the tree set constructors. So there are 4 constructors available in the tree set. The first one is tree set empty constructor. It tries to create an empty object. So if you are trying to add elements on that object, so the object would be sorted in the ascending order. This is the default sorting order. And second one, tree set collection. So it will try to create an object using the elements that are present in this collection C. Tree set compared to C, what it does is the default sorting order for the tree set is ascending order. If you need descending order or some custom or sorting order, then you can create a comparator object and then you can send the comparator object as an argument for creating the tree set object. So we'll talk more about the comparator in the upcoming videos. For now, just consider this way to override this default sorting order. And then comes the tree set sorted set S. What it does is it will try to create an object using the elements present in the sorted set object. So this is the syntax for creating the tree set object. So this is the roll number is the object for the tree set. So thanks for watching. So now we are going to see what is tree set using some real-time example. So before watching this video, please go and watch asset video and then linked asset video. So that will give clear and brief information about the usage of methods that are present inside the set interface. So yeah, the major difference between the asset and tree set is tree set maintains ascending order insertion, whereas asset doesn't maintain any order. If you are trying to add Rakesh and then Lenin and then Rakesh once again and then Raja, if you are trying to print the output, what you do is Lenin, Raja and Rakesh. The reason behind is L comes the first in alphabetical order and then comes here Raja and Rakesh both starts with R. So here comes the conflict and then it checks the second character A. Here also the conflicts and then comes to the third character J. Here K. So J comes first in the alphabetical order and then comes K. That's why Raja is at the second position and Rakesh is at the third position. So if we compare with the linked asset tries to maintain the insertion order Rakesh, Lenin, Rakesh, Raja. If you try to run this program, you would see Rakesh, Lenin, Raja. The reason behind is it maintains the insertion order. Similarly, in asset, it doesn't maintain any order at all. It stores the value using some logic, hashing logic at randomly. So that's the major difference between the tree set, asset, and linked asset. So please go and watch asset and linked asset videos for getting more information about the iterator method, contains method, isEmpty method, and etc. So thanks for watching. Now we are going to see what is map interface and how map interface is used in Java using some real-time examples. So this is map interface. Here you would see many abstract methods. So what I have done is I have picked out the best or frequently used abstract methods in real-time, and then I have listed here with description. So we will see about this in the later part of this video. First we will see what is a map. For example, suppose if you are working in a company, you would have some employee ID. That employee ID is used to point your data uniquely. For example, each employee has some unique ID, so that uniqueness is maintained here. So a particular unique ID can't point to two employees. Similarly, a particular key can't point to two or more values. Or a key can have one-to-one relationship physically. So if suppose employee 1 points to some data, employee 2 points to some data, employee 3 points to some data. So the keys are always unique. Suppose if you are trying to add a new key that was already present in the existing map, means it will overwrite data. If suppose one Raja, now if you are trying to add one Rakesh, means the latest map value would contain one with value Rakesh. And then what put on means, if suppose there are two companies, company A and company B, company A has 100 employees and company B has 50 employees. If suppose a company A is suppose if a company A is taking over the company B, means all the employees who are working in the company B moves to company A. So all the company B details, company B employee details moves to company A employee details. Similarly, put on. So if suppose if you want to add all the data that is present in a particular map to another map, means you can use a put on. And then remove means if suppose if you are trying to remove a particular key, if suppose if a person having employee ID of 90 is trying to move to other company, means that employee ID can be removed using this method, remove employee ID. So what it does is it will try to remove the corresponding value also. And then get means if you are trying to access a particular data using key, means you can use get. Suppose if you are trying to access the employee 90 data, means you can send just 90, that will return the employee 90 data. And then contains, here what it does is it will try to check whether that key is present in that map or not. If suppose that key is present, means it will return true, otherwise it will return false. Key set. This is used to return all the keys that is present in the map. So in the next video we would see hash map. Now we are going to see what is linked hash map and how we can use linked hash map in Java. So before watching this video, please go and watch hash map video. That is previous video, so that you could get more information about the linked hash map. So the major difference between hash map and linked hash map is linked hash map maintains the order based on key value, key data. If suppose if you are trying to add 1, 2, 3, 4, this is first statement, second statement, third statement, fourth statement, it tries to maintain the order how you have inserted. So first statement key will be present as somewhere, and second statement key will be present after first statement key, like that. It maintains the insertion order based on key data. So whereas in hash map it doesn't maintain that order, so it randomly maintains the order. So that's the major difference between linked hash map and hash map. And then I have already explained about these statements in the previous video. So please go and watch the hash map video for getting more details. So thanks for watching. Now we are going to see about the tree map properties, tree map class interface diagram, tree map example. So tree map is one of the implemented classes of map interface. So all the methods, all the abstract methods that are present in the map interface would be implemented in this implemented class. The map interface properties would also suit the tree map properties. That's these two properties. These two properties belong to map properties. So since this is an implemented class, that map properties also belongs to tree map properties. Contains values based on keys, contains only unique keys. I've already talked more about these two things in the previous videos. So I'm just skipping those explanations for now. And then there is the class interface diagram for the tree map. Tree map implements map, sorted map, navigable map, directly and indirectly. So all the methods, abstract methods that are present in these three interfaces should be implemented here. And these are the two distinguishing properties. The first property cannot contain null key. Hash map and the linked hash map allows maximum of one null key, but tree map doesn't allow that. This property is common to all the three implemented classes. Can contain multiple null values. It's applicable for hash map, linked hash map, and tree map. And the second distinguishing factor is maintains sorted order. Hash map doesn't maintain any order. Linked hash map maintains insertion order, whereas tree map maintains the sorted order. The default sorted order would be ascending. If you need to custom the order sorting, you can write the comparator object. We will talk more about that in the upcoming videos, how to send the comparator object so that you can send the custom sorting order. For now, just consider this example. Here we will try to explain about this tree map using the three entries. The first entry would be 100, artist. So since there is an empty object, that would be added here. Next 99, also. Since this is the tree map, 99 value is lesser than 100, so that would be added first, and the 100 would be shifted next. So here the sorting happens, and then 101 then. Since 101 is higher than 100, it would be appended at the end. So this is the sorting also applicable here. So 99 under 101 is in sorted order, in ascending order. If suppose we need to sort in the descending order, you can also do that. Thanks for watching. Now we are going to see what is a stack and how we can use stack in real-time world and how stack is being implemented in Java, and we have written a basic program for explaining stack. So this is stack, basic program. So the basic principle behind stack is last in first out. So the elements that are added recently would be removed first, and then the elements that are added in the successive way. So for example, if you are trying to place a book on a table, so you're trying to place first book, and then on the first book you're trying to place second book, similarly up to 10 books. So if you're trying to distribute the books, what you do is you will try to pick the first book, you are trying to pick the topmost book, and then the next, and then the next. So here what I'm trying to convey is the book that was added last would be removed the first, and then the next, and then the next. That's the basic principle of stack. Last in, first out. So this is a basic program of stack. So stack is a class. What we're trying to do is we're trying to tell the type of the object, string stack object, stack.push 1, 2, 3. So if you're trying to run this program, you will see 1, 2, 3, and then suppose stack. If you want to view the topmost element, you can do that by using stack.peek. So if you run this program, you would see stack topmost element 3. If you are trying to return the topmost element, and simultaneously if you need to remove that element, means you need to give stack.pop. So what it does is it will try to return 3 and simultaneously remove the 3 from that stack. So then the defined stack is 1, 2. This is the basic program about stack. So now we are going to see what is a priority queue and how we can use priority queue in Java, and what are the image advantages of priority queue. So before moving to priority queue, we will first discover about the queue. If you are trying to book a ticket in a railway station, what you do is you would stand in a queue and you will try to book a ticket. Here, the person who is standing at the first would be given preference. So here, first in first out, based on first in first out price. Whereas in priority queue, the principle is slightly different. Here in priority queue, it gives preference to some people or some elements based on some ordering. So basically, priority gives preference to natural ordering. Natural ordering means, suppose if you are trying to hold the elements, string elements, means it gives preference based on the alphabetical order. If you are trying to hold the elements of integer, means it gives based on ascending order. So if you want to hold this ordering, you can do using comparator overriding operation. So what we have done is we have created object of priority queue, and then we added Rakesh line and Chenchu. Suppose if you are trying to run this program, you would see this support Chenchu Rakesh line. The reason behind here is Chenchu comes first in the alphabetical order, and then Rakesh, and then Denny. And then what we have done is we are trying to get the topmost head of the element using peak. So peak returns the head of the element. So it returns the Chenchu. If you want to get the head of the element and simultaneously remove the head of the element, means you need to use dot pole. So what it does is it will remove the pole, it will remove the Chenchu, and then returns, and then the refined priority queue is lane and Rakesh. So thanks for watching. Now we are going to see what is a vector and how we can relate vector with ArrayList and using some example. So what is a vector? So it's very similar to ArrayList, but technically differs in two cases. So vectors are synchronized, whereas ArrayList are not synchronized. So synchronized and not synchronized. We will talk about this synchronized and not synchronized in the upcoming videos. For now, just consider synchronized means that thread safety is automatically enabled. So if suppose multiple threads are accessing the vector object, means internally it's getting handled, whereas not synchronized means you need to ArrayList objects need to maintain, and we need to explicitly maintain the thread safety. So we talk more about thread safety and related things in the upcoming videos. So and then that in terms of memory, vector doubles size whenever the size is this capacity, whereas in ArrayList it increases size by 50%. For example, suppose if you are creating the object for books using vector object means the default size of book should be 10. If suppose 10 reaches, means what the vector does is it will increase the memory by 2 times, so it reaches 20. Whereas in ArrayList it increases by 50%. So if suppose 10 reaches, means it will increase to 15. So that's the major difference between the vector and ArrayList. So thanks for watching.